This is a short lesson on simplifying simple radical expressions. Uh, and what the deal is that we can't leave anything that's a perfect square inside of any of the numbers as factors of any of the numbers or variables that are under the radical sign. So to simplify it, we have to take out things that have a perfect square root. Now 60 is not a square number. There's no even number square root of 60. But what we do is we take the number and we can break it down using prime factorization. So I always start with dividing by 2 times 30 and 2 times 15, and then I go up to 3 since 2 does not go evenly into 15 times 5. So 2 times 2 times 3 times 5. So that means that the square root of 60 can be rewritten as the square root of 2 times 2 times 3 times 5. And then you can see that perfect square that is inside of 60, which is a 4. It's the 2 times 2. So whenever I have a pair, that means that a 2 can come out. So a 2 comes out because that's the square root of 4 times the square root of 15, or 3 times 5. But the 3 times 5 will stay in. Okay, so these guys stay in. So 3 times 5 is 15. And that's what, when I simplify the square root of 50, it is 2 root 15. Okay, so next let's go to 128ab squared. So let's prime factor the 128 for starters. This is 2 times 64, which is 2 times 32, which is 2 times 16, which is 2 times 8, 2 times 4, and a 2 and a 2. And you can see we've got a lot of pairs of 2 under there. Every time 2 times 2 is a perfect square, isn't it? Those are all 4s. Of course, you'll get better at this and you won't have to write all these in every time under the radical, but just to look at it, I've got 1, 2, 3, 4, 5, 6, 7 2s, right? 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, and then times an A, and then times a B squared, so B times B, if I expand it all out. And then we can see a 2 will come out here, a 2, the square root of 4 will come out here, the square root of this pair will come out here. So every time we have a pair, that represents a perfect square, and the square root will come out. So I have a 2 times a 2 times a 2 coming out. This 2 stays in. The A is a single power of A. Anything to the first power, this stays in, but there's a pair of B's, B squared, so a B will come out also. So all that we have left inside is the 2 and the A. And if I simplify this, 2 times 2 is 4 times 2 is 8. I get 8b times the square root of 2a. And that is this expression simplified with all of the perfect squares pulled out. Okay, so the last one, and you know, when you get better at this, you'll just go, oh, you know, it's 4 times 15. So a 2 will come out and a 15 will stay in, etc. Anyway, 75, let's take apart 75. 2 does not go into 75. The next prime number would be 3, and 3 does, because 75 is 3 times 25, and then 25 is 5 times 5, and those are also both prime numbers. So I get 3 times the square root of 3 times 5 times 5. And if I look at a to the 5th, there's, you know, let's just make all 5 a's. A times A times A times A times A, completely expanded. But you'll see the pattern of how to do it more simply in a few minutes. So I've got a pair of 5s. So 1 5 will come out to the front and multiply by this 3. That 3 will stay in. I have a pair of A's, so another A will come out. A pair of A's, so an A will come out. And this A will stay inside. So I have times the square root of 3a. Okay, so this is 15a squared is outside the radical times the square root of 3a. And that's if you do it completely expanded. But eventually you'll be able to see that this breaks into, you go down to the next even number, if you're looking for a perfect square, it would be a to the fourth times a to the first. And the square root of a to the fourth would be a squared. A to the second times a to the second would be a to the fourth. So you could pull out an a squared right here and leave the a in if you don't want to write it out all expanded. But this works when you're first starting off. So that's it, simplifying radicals.